A rock breaks loose from the top of a tall cliff. What is the average speed during the first 2 seconds of fall? What is the average speed during the 1 second interval between second 1 and second 2? Find the speed of the falling rock at t equals 1 second and then at t equals 2 seconds. The third part asks for an instantaneous speed at each instant when t equals 1 and when t equals 2. First, we recognize that this is a projectile motion, and from algebra we know that the position for any projectile motion is s of t equals 1/2 times the gravity times t squared with the minus in the front, plus the initial velocity times t plus the initial position s sub 0, where s sub 0 is the initial position, v sub 0 is the initial velocity when time equals 0, and g is the gravity. The gravity g is either 9.8 meters per second square if the metric unit is used, or it is 32 feet per second square if the customary unit is used. In this case, it is not clear whether meters is used or feet is used, and so we're going to have to pick one. It doesn't really matter which. If we choose the metric unit meters, then we have to use the gravity 9.8. But if we were to use the customary unit feet, then the gravity is 32. I'm going to use the customary units, so the gravity is going to be 32 feet per second squared. Alright, so s of t is negative 1/2. The gravity is 32 t squared plus the initial velocity is 0 because the rock breaks loose. No force was applied to the rock, and so the initial velocity is 0. The rock just simply let go. Times t plus the initial height. We were not told the height, but we can assume that because this is the cliff, the initial height is the ground level 0. And so the position function of the rock is simply minus 16t squared. Just a simple expression. Part A. What is the average speed during the first 2 seconds of fall? We are looking for the average rate of change on the interval 0, 2, the first 2 seconds. We know that to find the average rate of change, we only need to know the beginning when time is 0 and the ending on this interval when time is 2. We need to also evaluate the position of the rock at the 2 instances. When t is 0, s is minus 16 times 0 squared, which is 0. And when t equals 1, s is minus 16 times 4, which is minus 64. The average velocity between these 2 instances is therefore the ending position minus the beginning position over the time elapsed, which is 2 seconds here. The result is minus 32 feet per second. This is simply the slope of the secant line between the 2 points 0, 0 and 2, minus 64. Part B. What is the average speed during the 1 second interval between second 1 and second 2? we basically do the same thing, except that this time the beginning time is 1 second and the ending time is 2 seconds. And so when time equals 1, the position is minus 16, which is 16 feet below the ground. And when time is equal to s sub 2 is still negative 16 times 2 squared, which is negative 16 times 4 minus 64. And so the average speed is the ending minus the beginning over the times elapsed. There's only 1 second here. Compute this, we have negative 48 over 1, or negative 48. The unit is feet per second. What this means is that on average, during t equals 1 and t equals 2, the rock is falling at the rate of negative 48 feet for every second.